Okay, I think we get a little sound check. Sound checking. Okay, I think we get a little sound check. Yeah, everything's good. Again, we'll wait for Thingy to catch up and then we'll get cracking. We're almost at the end of this now, so see how well tonight goes. We might not need the stream tomorrow, but we'll see. Right, we're back live now, peeps. Let's get the window share on the go. Oh, gotta do the old mystic dance. There we go. Happy days. Right. We've got 1, 2, 3, 4, 5, 6. Got 6 more chapters the same. We're kind of halfway through this one, so let's have a go at this. So let's get cracking. We're back on Go packages and modules. So let's get a thingy of this. So it's saying my package, remote, preferred remote source provider, github.com. github.com, username. I think mine's just tech. Okay, whoops. Oh no, I did it. So look at that. Run this. Yay. Okie dokie. That's the easy one, so let's go next. Go run. So the go run command. So it's all about packages and modules in this one, and just basically just going through it, creating your own package and just running a custom thing, I guess, which is all good. The go run command quickly compiles and runs a Go package. The compiled binary is not saved in your working directory. I typically use go run to do local testing, scripting, and debugging. Inside hello go, create a new file called main.go. Conventionally, the file in the main package that contains the main function is called main.go. It's just a thing. Then, yep. Then paste the following into your file. Yep. Then run the code. Ta-da! Simple. So package main, import fmt, function that. And I'm pretty confident we just run this in one go. Yay! So go build command, go build command compiles Go code into a single statically linked executable program. One of the beauties of Go is that you always go build for production, and because the output is a statically compiled binary, you can ship it to production or end users without them needing the Go tool chain installed. Some new Go devs use Go run on a server in production, which is a huge mistake. Ensure you are in your hello, then run this, and then run the new program. Ta-da! You see the binaries there. Very nice. Go install. So go install command compiles and installs a package or packages on your local machine. Let's go back a thing a step. Go mod in it. occurring to your personal usage. It installs the package binary. It installs the package's compiled binary in the go bin directory. We installed the Boot.dev CLI with it after all. Ensure you're in your hello go repo, then run this. Let me just cat the thing again. Whoops. Imagine. Okay, just tells the version. So go install. I think I already did that. Navigate out of your project directory. If all went well, go compiled and installed hello program globally in your machine. Okay. Yeah. If you get an error regarding hello go not found, it means you probably don't have Go environment set up properly, blah blah blah. That's all fine for me. No probs. Hey, this is an easy lesson to get through, I'll tell you that. Yeah. A custom package. So let's write a package to import and use hello go. Navigate to the parent directory of hello go in your shell from the last session you open, and then we're already there, so cd like that, we're back in. Create a mystrings directory as a sibling directory in hello go and navigate to it. It's all just simple trudgery stuff. Initialize a module. So it's going to be github.com/tech like that. Create a new mystrings.go in that directory. Mystrings.go. So touch mystrings.go. Is that right? And then mystrings.go. Paste that. By convention, we name our package the same as the directory, so package mystrings. Reverse is a string from left to right. Notice that we don't need to capitalize the first letter of the function. If we don't, then we won't be able to access this function outside of the mystrings package. Only capitalized names are exported, meaning they can be accessed by other packages. Uncapitalized names are private. Notice there is no main.go or main function in this package. Run go build because this isn't the main package, it won't build an executable. However, go build will still compile the package and save it to your local build cache. It's useful for checking for compile errors. Okay, so go build. Run and submit CLI tests, blah 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 blah. Easy squeezy. Oh, you know what I should have done? I'm going to do it now. I'm going to put on a little extra potion. So let's use my mystrings package in the hello go. So modify the hello go's main.go file with the below code. Don't forget to replace remote and username with the values you used before. Okay. So neovim main.go. So guess that. github.com/LiamWalsh.tech. Follow this example and update the main go.mod file to import the local version of the mystrings dependency. Go mod. I'd love to know how to do multi-line with Vim. Okay. Tells // my strings tells Go to look in the parent directory of hello Go for the my strings sibling directory. Oh, hold on. Did I build it in the wrong? So if I run this, I got a feeling this might fail actually. Whoops. Whoopsie daisy. Okay. Put it in the wrong thing. Whoopsie daisy. Yay. I should have put it in the directory above side by side as a sibling, not don't think. New version of the app is available. Click refresh. Thank you, new version of the app. Remote packages. So let's learn how to import and use an open source package that's available on GitHub. So a note on replace. Be aware that using the replace keyword, like we did in the last assignment, is not advised, but can be useful to get up and running quickly. The proper way to create and depend on modules is to publish them to a remote repository. When you do that, the replace keyword can be dropped from the go.mod. This only works for local only developments. Yeah. If we want the import to work for everyone, we need to make sure the dependency mystrings in this case exists on github.com/wagslane/mystrings. Assignment: create a new directory in the same parent directory as hello go mystrings called data test. So mkdir. Oh, date test. Whoops. Create a main.go in the data test and add the following code. I guess, and then such. Was it main.go? Main.go. And then initialize a module. github.com/ianwalsh.tech. So it says download and install the remote Go tiny time package using GoGet. Okay. Print the contents of your Go mod file to see the changes. Compile your program and run this. Okay. So require GitHub, blah, 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 indirect. Yay. Clean packages. I've often seen and have been responsible for throwing code into packages without much thought. I've quickly drawn a line in the sand and started putting code into different directories, which in Go are different packages by definition. Just for the sake of organization, learning to properly build small and reusable packages can take your Go career to the next level. So rules of thumb, hide internal logic. If you're familiar with the pillars of object-oriented programming, this is a practice in encapsulation. Oftentimes, an application will have complex logic that requires a lot of code. In almost every case, the logic that the application cares about can be exposed via an API. And most of the dirty work can be kept within a package. For example, imagine we are building an application that needs to classify images. We could build a package like this. So package classifier, classify image, classifies image as a hot dog or not hot dog. Has hot dog shape, internal logic that the application doesn't need to know about. More things, so has hot dog colors. We create an API by only exposing the function or functions that the application level needs to know about. All the logic is unexported to keep a clean separation concerns. The application doesn't need to know how to classify an image, just the result of the classification. Remember, in Go, functions with names start with a lowercase letter, are unexported and private to the package, while functions starting with an uppercase letter are exported and can be accessed externally. Don't change APIs. The unexported functions within a package can and should change often for testing, refactoring, and bug fixing. A well-designed library will have a stable API so that users don't get breaking changes each time they update the package version. In Go, this means not changing exporting function signatures. Don't export functions from the main package. So a main package isn't a library. There's no need to export functions from it. Packages shouldn't know about dependents. So perhaps one of the most important and most broken rules is that a package shouldn't know anything about its dependents. In other words, a package should never have specific knowledge about a particular application it uses. Should you export Go from the main package? Nope. Then the next question is the same information on the left. When should you not export a function, variable, or type? When the end user doesn't need to know about it? Never. It's better to share code. Ooh. Nope. Should you often change a package's exported API? Yes, move fast, break things. No, try and keep changes to internal functionality. If the package is main, then yes. Concurrency. Okay, so channels, and we got how many lessons in this one? 11. This is going to be interesting. Let's see how we do. Oh.
And how it can be used to make your applications faster. Take this simple code. X equals 5, X plus plus, and print X. This is sequential or synchronous code. Each line runs one after the other. First, X is set to 5, then it's incremented, then it's printed. Nice and easy. But this isn't always the fastest way to run code. And to understand why, we need to talk about your CPU. Every CPU has a clock speed, which is a matter of how many clock cycles it can perform per second. For example, a 3.5 gigahertz CPU can perform about 3.5 billion clock cycles per second. And in our example for
1 minute, we'll start this again in a second. Hold on. Important job of the day. Important job of the day is done. Let's just start the video again.
Let's break down what concurrency is and how it can be used to make your applications faster. Take this simple code. X equals 5, x plus plus, and print x. This is sequential or synchronous code. Each line runs one after the other. First, x is set to 5, then it's incremented, then it's printed. Nice and easy. But this isn't always the fastest way to run code. And to understand why, we need to talk about your CPU. Every CPU has a clock speed, which is a measure of how many clock cycles it can perform per second. For example, a 3.5 gigahertz CPU can perform about 3.5 billion clock cycles per second. And in our example from before, I know this is an oversimplification, but we can say that we have 3 instructions to carry out: setting x to 5, incrementing x, and printing x. And how fast we can execute these instructions depends on our hardware. To make the program faster, we can either reduce the number of executions the program needs to execute, or use a CPU that can execute more instructions per second. But let's assume that we can't really optimize our program anymore. And faster CPUs are expensive and they have physical limits. So instead of increasing the clock speed, it's actually often more cost effective to instead increase the number of CPUs, or specifically increase the number of cores within the CPU. You've probably heard of quad-core processor, and that just means 4 separate cores all in one computer. Say each core can handle about 3 billion instructions per second. Well, if we have 4 of them, now we can potentially do 12 billion instructions per second, but only if we can actually execute all the instructions in parallel. And that's the catch. Not all programs can easily make use of multiple cores at the same time. Again, take our earlier example. Setting x to 5, incrementing x, and printing x, we can't parallelize this because the instructions depend on each other. We can't increment x before it's initialized, and we can't print x before it's incremented. But let's say that we added some more code. Y equals 6, y minus minus, and print y. Now, these 2 blocks are actually independent of each other. So we can assign one block to one core and the other block to the other. Now, sure, if we ran both blocks on a single core, it might take 6 CPU cycles. Again, I'm waving my hands here. But if we split the 2 blocks and run them on 2 different cores, then each core can actually work in parallel at the same time. And the whole program finishes in roughly half the time, 3 cycles. So when we're dealing with compute-intensive logic, we usually want to structure our code so that big sections of it can run in parallel to take advantage of all the cores that are available on the machine.
So concurrency, what is concurrency? So concurrency is the ability to perform multiple tasks at the same time. Typically our code is executed one line at a time, one after the other. This is called sequential execution or synchronous execution. So synchronous execution and concurrent execution, one after the other, side by side. If the computer we're running our code on has multiple cores, we can execute multiple tasks at exactly the same time. If we're running on a single core executes code at almost the same time by switching between tasks very quickly. Either way, the code we write looks the same in Go and takes advantages of whatever resources are available. So how does concurrency work in Go? Go was designed to be concurrent, which is a trait fairly unique to Go. It excels at performing many tasks simultaneously safely using a simple syntax. There isn't a popular programming language in existence where spawning concurrent execution is quite as elegant, at least in my opinion. Concurrency is as simple as using the go keyword when calling a function. So go, do something. In the example above, do something will be executed concurrently with the rest of the code in the function. The go keyword is used to spawn a new go routine. Let's have a brief look at that. A go routine is a lightweight thread of execution. I'll come back to that. So at Textio we send. Are we expected to read that and then kind of come back? Oh, I'll read it then. Suppose we have a function called f. It takes s as a string. Here's how we call that the usual way, taking it synchronously. To invoke this function in a go routine, use go f string. This new go routine will execute concurrently with the calling one. You also start a go routine for an anonymous function call. Two function calls are running asynchronously in separate go routines now. Wait for them to finish. For a more robust approach, we use wait group. Then we run the when we run the program, we see the output of the blocking call first, then the output of the two go routines. The go routines output may be interleaved because go routines are being run concurrently by go runtime. So a brief look at that. Wait groups. To wait for multiple go routines to finish, we can use wait group. I did use wait before. I didn't really. To wait for multiple go routines to finish, we can use a wait group. This is a function will run in every. This is the function will run in every go routine. Sleep to simulate the expensive task. This wait group is used for all the go routines launched. Here to finish. Note if a wait group is explicitly passed into the functions, it should be done by pointer. Launch several go routines using waitgroup.go. Block all go routines started by WG are gone. A go routine is done when the function it invokes returns. Note that the approach has no straightforward way to propagate errors from workers. For more advanced use cases, okay. So assignment. At Textio, we send a lot of network requests. Each email we send must go out over the internet. To serve our millions of customers, we need a single Go program to be capable of sending thousands of emails at once. Edit the send email function to execute its anonymous function concurrently so that the received message prints after the sent message. Edit the send email function in its anonymous function concurrently so that it receives message right after. Okay, so say go like that. Yep, easy peasy. Channels. So channels are a typed thread-safe queue. Channels allow different go routines to communicate with each other. Like maps and slices, channels must be created before use. They also use the same make keyword. Send data to a channel. The arrow operator is called the channel operator. Data flows in the direction of the arrow. This operation will block until another go routine is ready to receive the value. Receive data from a channel. This reads and removes a value from the channel and saves it to the variable v. This operation will block until there is a value in the channel to be read. Reference type. So like maps and slices, channels are reference types, meaning they are passed by reference by default. Actually, channels are reference types means they are passed by reference by default. Okay, blocking and deadlocks. Excuse me. A deadlock is when a group of go routines are all blocking, so none of them can continue. This is a common bug that you need to watch out for in concurrent programming. Assignment. Run the program. You'll see that it deadlocks and never exits. The send is old function. Oops, not that. Let's do that. The send is old function is trying to send on a channel, but no other go routines are running that can accept the value from the channel. Fix the deadlock by spawning a go routine to send the is old variable. Okay. So it's got channel is old channel. Send is old. You see the deadlocks. It never exits. The send is old. Function is trying to send on a channel, but no other Go routines are running that accept the value from the channel. Fix the deadlock by spawning a Go routine to send the is old values. So go like that. So in program, you'll see the deadlock. Right, let me read that again. So create channel, send data to the channel. So we did that. We send data to the channel. Operator is called the channel operator. Data flows in the direction of the arrow. This operation will block until another Go routine is ready to receive the value. Receive the value from a channel. This reads and removes the value. Blah blah blah. Reference label slices. Channel reference types, meaning they are passed by reference and default. So a deadlock is when a group of Go routines are blocking, so none of them can continue. This is a common bug you need to watch out for in thinking. So run the program, you'll see the deadlocks and it never exits. The send is old. Function is trying to send on a channel, but no other Go routines are running that can accept the value from the channel. Okay, I'm not quite following this part, but we'll go with it. Channels. In the previous lesson, we saw how we can receive values from channels like this. However, sometimes we don't care what is passed through a channel. We only care when and if something is passed. In that situation, we can block and wait until something is sent on a channel using the following syntax. This will block until it pops. This will block until it pops a single item off the channel, then continue, discarding the item. In cases like this, empty structs are often used as a unary value so that the sender communicates that this is only a signal and not some data that is meant to be captured and used by the receiver. Here's an example. So download data. Download done channel. So print on a downloading file, data sleep time. Process data. Block until download data sends a signal that it's done. Okay. So assignment, our Textio server isn't able to boot up until it receives the signal that its databases are all online, and it learns about them being online by waiting for tokens, empty structs on a channel. Run the code, it never exits. The channel passed to wait for DB stays blocked because it's only popping the first value off the channel. Fix the wait for DBs function. It should pause execution until it receives a token for every database from the DB-chan channel. Each time wait for DBs reads a token, the get DBs channel go routine will print a message to the console for you. The succinctly named num DBs Input is the total number of databases. Look at the test code to see how these functions are used so you can understand the control flow. So it's num. Okay, run the code, error exits, blah, blah, blah. It should pause execution until it receives a token for every database from the DB channel. Each time, wait for DBs, reads a token, the get DBs channel go routine will print a message to console for you. Succinctly named them. So look at numDBs. Right, so what am I meant to do here? Fix the wait for DBs. Fix the wait for DBs function. It should pause execution until it receives a token for every database from the DB channel. Each time wait for DBs reads a token, the get DBs channel go routine will print a message to the console for you. The succinctly named numDBs input is the total number of databases. Look at the test code to see how these functions are used so you can understand the control flow. So, wait for DBs. Look at the test code to see how these functions are used, and you can understand the control flow. Just goes on forever. Right, I'm not sure what to do here. Not sure what the thing's asking. Let me have a look for wait for DBs. No idea. They're just num DBs. That's a non-channel to int numbers, variable int type. It's just a case of putting a for loop around it. Wait for DBs. Channel passed away for DBs. Tables blocked. Because it's only popping the first value off the content. Fix wave ups. It should pause. Fix the wait for DBs function. It should pause execution until it receives a token for every database from the DB channel. Each time wait for DBs reads a token, the get DB channels go routine will print a message console succinctly named. I feel like I have to get boots for this one. I'm like, what? I'm tired today. Boots. Help me out. I don't really know what it's asking me, to be honest. I'm kind of a bit clueless. I've got you worried, Traveler. I can see your code in the output. Couple of questions for you. Your wait for DBs only reads once from the channel. How many databases might there be? If there are n databases, how many tokens will be sent to DB-chan? Given that, how many times should wait for DBs read from blah 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 blah? Well, didn't I kind of do that? So like 4. Huh? Let's see if it finishes running. I stopped it last time, so it might just be, it takes a little bit of time. No? What about now? Close but small goism is tripping you up. You can't range over in of. Alright, okay. Range works on iterables like slices, maps, and channels. Here you want it to counter loop. Blah, blah, blah. What kind of loop in Go lets you run something exactly n times? How could you write? So it blocks channel n times. So for if I is less than num-db channels, then I plus. There we go. Just didn't know what it was asking me. I'm like, God, sleepy brain today. It's been a long day, but we'll try and get through as much as we can. I say if we can get up to, I should see how far we get. Buffered channels. So channels can be channels can optionally be buffered. Creating a channel with a buffer. So you can provide a buffer length as the second argument to make to create a buffered channel. So channel, make that. A buffer allows the channel to hold a fixed number of values before sending blocks. This means sending a buffered channel only blocks when the buffer is full and receiving blocks only when the buffer is empty. Read that again. So you can provide a buffer length as a second argument to the make to create a buffered channel. A buffer allows the channel to hold a fixed number of values before sending blocks. This means sending on a buffered channel only blocks when the buffer is full and receiving blocks only when the buffer is empty. So assignment. We want to be able to send emails in batches. A writing Go routine will write an entire batch of email messages to a buffered channel, and later, once the channel is full, a reading routine will read all the messages from the channel and send them out to our clients. Complete the add emails to queue function. It should create a buffered channel with a buffer large enough to store all the emails it's given. It should then write the emails to the channel in order to finally return the channel. So it's channel equals make, and then it's going to be channel string, I guess. That's going to be length of emails. Then it should write the emails to the channel in order, and finally return the channel. So I guess return channel. Right. Channel, and that's going to be emails, something like that. Yeah, it's a little bit of a weird concept to get my head around, but we get there. Closing channels in Go. So channels can be explicitly closed by a sender. So do some stuff with the channel, then close it. Checking if a channel is closed. So similar to the OK value when accessing data in a map, receivers can check the OK value when receiving from a channel to test if the channel was closed. OK is false if the channel is empty and closed. So don't send on a closed channel. Sending on a closed channel will cause a panic. A panic on the main Go routine will cause the entire program to crash. And a panic in any other Go routine will cause that Go routine to crash. Closing isn't necessary. There's nothing wrong with leaving channels open. There'll still be garbage collected if they're unused. You should close channels to indicate explicitly to a receiver that nothing else is going to come across. So the assignment. At Textio, we're all about keeping track of what our systems are up to with great logging and telemetry. The send reports function sends out a batch of reports to our clients and reports back how many were sent across a channel. It closes the channel when it's done. Complete the count reports function. It should use an infinite for loop to read from the channel. Isn't there like a while type of loop? So like for hold on. Use the infinite for loop to read from the channel. If the channel is closed, break out the loop. So, okay. So v num since channel, and I think we go what was it like? Well, no, okay, or conditionals. Okay, is not equal to nil. If the channel is closed, break out the loop. So if I guess like if okay is not equal to nil, then a break. Otherwise, keep a running total of the number of reports sent, turn the total to the report sent. I guess running total 0. Running total plus. Something like this. My brain is really struggling. What did I do wrong? Go short and if. Closes. Line 5. I just done the basic variable wrong. Unexpected new line. Line 6. I feel like I'm definitely losing something here. This is not going very well. I'm just struggling with this. Like, brain is not optimal right now. I just getting the wrong end of the stick. This is serious. I'm falling asleep. So what type is the OK value from that when receiving from a channel? Is it a boolean or something that can be nil? Yeah. In your loop, how could you repeatedly see receive from the channel, update a running total by receiving update a running total by receiving a request and stop the channel when it's closed? You want to receive inside the loop each time. Use OK value to decide when to break. I think that was right. Use OK value to decide when to break. Add the received integer to your total instead of just increment by 1. Oh, I see. Right, hold on. Percent. Oh. Whoops, my brain definitely not okay. So if it's okay, then do that. All right. It's not going to be, well, it's not an error. It's just it returns true or false. My brain isn't working. I close. Oh dear. You're close. One key wrinkle goes for loop. Can't declare no center in the loop header like that. Finally got it. So similar to slices and maps, channels can be ranged. Oh god, I'm so tired. Like, let me go turn up the heating. Right. So similar to slices and maps, channels can be ranged over. Okay. So item is the next value received from the channel. So this example will receive values over the channel, blocking each iteration if nothing new is there, and will exit only when the channel is closed. Assignment. It's that time again. Textio is hiring and we've been assigned to do the interview. The Fibonacci sequence is Textio's interview problem of choice. We've been asked, we're building a small toy program we can use in the interview. So complete the concurrent Fibonacci function. It should create a new channel of ints. So chan ints. I think it's make. I've forgotten the syntax again though, so it's going to be channel of int. Call Fibonacci concurrently. So say go Fibonacci. Use range. Use a range loop to read from the channel and append the values to slice, return the slice. Item in range chan ints. So I guess values. I forgot how to do a simple slice. Hold on. Slice. Ints. Just be like that. So it would be value. So it would be append values item. And it'll be return values. Oh, whoops. Forgot that. Slices and go. Make array events. Nope, this is going to be an int with an open. You like that? So go empty slice. Empty slice. Guess it could be n like that. Is not used. So initialize slice. Seven. Bio type. What? Oh, I forgot the thing. Right, you have to do this. I forgot that. Goes a little nuance with that. Alright, well, it did something at least, which is better than before. Failed, but it did something. That. I use it as a Go argument, why not? Right, like that. What am I doing? I'm completely goofing this up all over the place. I am like tired drunk. Right, okay, what's it yapping about? So I think the main problem is this part. There we go. Got brain is not fully switched on tonight. I have to do my best. I think I need to at least get to like 14 or something. Try and be able to wrap it up tomorrow night. So, select. Sometimes we have a single Go routine listening to multiple channels and want to process data in the order it comes through each channel. A select statement is used to listen to multiple channels at the same time. It is similar to a switch statement but for channels. So select case I, okay, is equal to something coming in from the channel, int. Okay, so, okay. So we have a single Go routine, listen to multiple channels. I want to process data in the order it comes through each channel. A select statement is used to listen to multiple channels at the same time. It is similar to a switch statement but for channels. The first channel with the value ready to be received will fire and its body will execute. If multiple channels are ready at the same time, one is chosen randomly, then OK variable in the example above refers to the whether or not the channel has been closed by the sender yet. Assignment. Complete log messages function. Use an infinite for loop and a select statement. So for and then a select statement to log emails, blah, blah, blah. To log the email messages and SMS messages. Messages as they come in order across two channels. Add a condition to return from the function where one of the two challenge closes, whichever is first. Add a condition to return from the function when one of the two channel closes, whichever one is first. Finished equals false. I guess for call it channel closed, channel closed. I guess if okay, do that, else return. Same with this. So if okay, do this, else, oops, else return. Oh, there's like a log email function here, hold on. Yay! I still got a thing. I'll pop it on. So select default case. The default case in a select statement executes immediately if no other channel has a value ready. A default case stops the select statement from blocking. Receiving from channel would block, so do something else. Ignoring channels. So sometimes you want to ignore a channel's value. If you can do this by not binding it to a variable. Ignored. Alternatively, you can use the blank identifier to ignore the value. Tickers. So time.tick is a standard library function that returns a channel that sends a value on a given interval. Time.after sends a value once after the duration has passed, and time.sleep blocks the current go routine for the specified duration of time. Time.sleep blocks the current go routine for the specified duration of time. The functions take a time.duration as an argument. For example, time.tick 500 times time.millisecond. If you don't add time.millisecond or another unit, it will default to nanoseconds. That's taking a wild guess here, probably faster than you want it to be. So read only channels. So a channel can be marked as read only by casting it from chan to I forgot what that's called, like the pointery thing, like to a chan type, for example. CH can only be read from in this function. Okay. So write-only channels. The same goes for write-only channels, but the arrow's position moves. A channel can only be written to in this function. Assignment. Like all good backend engineers, we frequently save backup snapshots of the TextDO database. Complete the save backups function. It should read values from the snapshot ticker and save after channels simultaneously and continuously. If the value is received from snapshot ticker, called take snapshot. If a value is received from save after, call save blah, blah, and return from there. If neither channels returned has a ready value. Okay. So that's this one, snapshot ticker. Okay. Take a snapshot. Snapshot tick. So if save after. Break, and then if neither channel has a value ready, call wait for data. And then time.sleep for 500 milliseconds. After that, we want to show in the logs that the snapshot service is running. Whoops. Read only. Okay, so if a value is received from snapshot ticker, do that. Take snapshot. If a value is received from save after, call save snapshot and return from the function you have done. If neither channel has a value, I think I don't need the if statements in this part. See what it does. Are you ready? Call wait data for then time. Whoops. Sleep. No, it's just not happening, this. What am I doing wrong? Do the value has a value ready. Wait for data log chain, then sleep for 8 milliseconds after all. Guess break or yeah, return. So it's going to do it in a loop or like that. Is that what it's wanting? Okay. I think that was me being too literal to the instructions, but it's okay. We'll get there. So channels review. So channels review. Here are a few extra things you should understand about channels from Dave Cheney's awesome article. A declared but uninitialized channel is nil, just like a slice. So S is initialized and not nil. A declared but uninitialized channel is nil, just like a slice. C is initialized and not nil. A send to a nil channel blocks forever. So C is nil. C, let's get started, blocks. A receive from nil channel blocks forever. A send to a closed channel panics. panic send on closed channel. A receive from a closed channel returns the 0 value immediately. What happens when you read from a nil channel? The receiver will block forever. What happens when you send to a closed channel? The sender will block forever. Oh no, panic, sorry. Okay, last example, ping pong. So many tech companies play ping pong in the office during break time. At Textio, we play virtual ping pong using channels. Assignment: run the code as is. You should see that it doesn't do anything interesting. No ping or pong messages are printed. Fix the bug in the ping pong function. Remember, if a program exits before its go routines are completed, those go routines will be killed silently. Which of the function calls probably shouldn't run in the background as a go routine? Yay! Right, let's see if we can get through mutexes quickly. And then it means tomorrow night is just a simple, 3 left. Let's have a look at generics. Enums, not a lot of enums, and then the quiz. Ooh. Mutexes, alright, we go. So, okay, mutexes in Go. Mutexes allow us to lock access to data. This ensures that we can control which Go routines can access certain data at which time. See again, mutexes allow us to lock access to data. This ensures that we can control which Go routines can access certain data at which time. Go standard library provides a built-in implementation of a mutex with the sync.mutex type and its 2 methods, so lock and unlock. We can protect a block of code by surrounding it with a call to lock and unlock as shown on the protected function below. It's good practice to structure the protected code within a function so that defer can be used to ensure that we never forget to unlock the mutex. I forgot what defer does now, but I think it runs at the end of a function thing. Yeah, okay, I'll say the rest of the function is protected. Any of the calls to mu.lock will block. Mutexes are powerful. Like most powerful things, they can also cause many bugs if used carelessly. Maps are not thread safe. So maps are not safe for concurrent use. If you have multiple Go routines accessing the same map, and at least one of them is writing to the map, you must lock your maps with a mutex. So assignment: we send emails across many different Go routines at Textio. To keep track of how many we've sent to a given email address, we use an in-memory map. We send emails across many different Go routines at Textio. To keep track of how many we've sent to a given email address, we use an in-memory map. Our safe counter struct is unsafe. Update the inc and value methods so that they utilize the safe counter's mutex to ensure that the map is not accessed by multiple Go routines at the same time. Note, WASM is single-threaded. Now it's worth pointing out that our execution engine on Boot.dev uses WebAssembly to run the code you write in your browser. WebAssembly is single-threaded, which awkwardly means that maps are thread safe in WebAssembly. I've simulated a multi-threaded environment with the slow increment and slow val functions. In reality, any Go code you write may or may not run in a single core machine, so it's always best to write your code so that it's safe no matter which hardware it runs on. So the assignment, so we send emails to keep track of them, keep track of how many we sent to a given email address. We use an in-memory map. our safe counter struct is unsafe. Update the inclusion functions and value functions so that they utilize the safe counter's mutex. To ensure that the map is not accessed by multiple coroutines at the same time. So I'm going to C dot lock, and then I guess c.mu dot unlock. Why is it called a mutex? So mutex is short for mutual exclusion. And the conventional name for the data structure that provides it is mutex, often abbreviated to MU, mutual exclusion. Computer science, mutual exclusion is a property of concurrency control, which is instituted for the purpose of preventing race conditions. It is a requirement that one thread of the execution never enters a critical section while a concurrent thread is in execution is already accessing said critical section. It's called mutual exclusion because a mutex excludes different threads or coroutines from accessing the same data at the same time. What does term mutex refer to? Mutual exclusion. Oh. Reload. Oh, come on, Boot. Mutual exclusion, got it. Something's really slowing down here. Lane, I hope Boot.dev is not running on AWS today. That'll be causing a bunch of problems. So refresh. Yay, correct. Okay. Mutex review. Oh. The principal problem that mutexes help us avoid is the concurrent read-write problem. This problem arises when one thread is writing to a variable while the other thread is reading from the same variable at the same time. When this happens, a Go program will panic because the reader could be reading bad data while it's being mutated in place. Wait release, mutex shared resources, wait release, yep. So mutex example, this. Write loop, read loop. Takes a map. The example above creates a map, then starts two Go routines, which each have access to the map. One Go routine continuously mutates the values stored in the map, while the other prints the values it finds in the map. If we run the program on a multi-core machine, we get following output: fatal error, concurrent map iteration, and map write. In Go, it isn't safe to read from and write to a map at the same time, so mutex is to the rescue. So same thing, we set up a mutex though, and then that mutex lock and unlock, lock and unlock. Stop program from exiting must be killed. In this example, we add a sync.mutex and named it mu. In the write loop, the lock method is called before writing, and then the unlock is called when we're done. This lock-unlock sequence ensures that no other threads can lock the mutex while we have it locked. Any other thread attempting to lock will block and wait until we unlock. If in the reader, we lock before iterating over the map, and likewise unlock when we're done. Now the threads can share memory safely. How many threads can lock a mutex at once? 1. Why would you use a mutex? To stop other packages from using my code, to safely access shared resources concurrently, to protect data from networking, to encapsulate private data members of a struct, to safely access shared resources concurrently. Okay, read write mutex. So the standard library also exposes a sync.readWrite mutex. In addition to these methods, lock and unlock, the sync read write mutex also has these methods for concurrent read. So rlock, so I'm guessing read lock and read unlock. Locks for reading. The sync rw mutex improves performance in read-intensive processes. Multiple Go routines can safely read from the maps simultaneously. As many read lock calls can occur at the same time. However, only one Go routine can hold a lock, and during this time, all read lock operations are blocked. Assignment. Let's update our same code from last assignment, but this time we can speed it up by allowing readers to read from the map concurrently. Run the new test suite. You'll notice that it hangs forever and you'll need to cancel it. Update val method to only lock mutex for reading. So rlock and then I guess unlock. Okay, so read and write mutex review. Maps are safe for concurrent read access, just not concurrent read write or write access. A read write mutex allows all readers to access the map at the same time, but a writer will still lock out all other readers and writers. Mutex allows all readers to access the map at the same time, but a writer, yeah. By using sync rw mutex, our program becomes more efficient. We can have as many read loop threads as we want while ensuring that the writers have exclusive access. How many writers can access rw mutex at once? 1. How many readers can access rw mutex at once? Infinite. Can readers and writers lock the rw mutex at the same time? No. generics. Got 10 minutes, see if we can smash through generics. Well, I have no idea what they are in this. So generics in Go. As we mentioned, Go does not support Go does not support classes. For a long time, that meant that Go code couldn't easily be reused in many cases. For example, imagine some code that splits a slice into 2 equal parts. The code that splits the slice doesn't care about the types of values stored in the slice. Before generics, we needed to write the same code for each type, which is a very undry thing to do. So like split int slice, and yeah. In Go 1.18, however, support for generics was released, effectively solving this problem. So type parameters. So simply put simply, generics allow us to use variables to refer to specific types. This is an amazing feature because it allows us to write abstract functions that drastically reduce code duplication. So in the square brackets, t, any, and then st, and then t is the type. Yep. Okay, I'm kind of like used to that syntax a little bit. In the example above, t is the name of the type parameter for the split any slice function, and we've said that it must match the any constraint, which means it can be anything. This makes sense because the body of the function doesn't care about the types of things stored in the slice. Assignment. At Textio, we store all the emails for the campaigns in memory as a slice. We store payments for a single user in the same way. Complete the getLast function. It should be a generic function that returns the last element from a slice, no matter the types stored in the slice. It should be a generic function that returns the last element from a slice. It should be a generic function that returns the last element from a slice. No matter the types stored in the slice. If the slice is empty, it should return the 0 value of the type. Okay, so I guess if length of s is equal to 0, then I guess return s. So if not, I guess it'll just be return s length of s, like that. Creating a variable at 0 value of a type is easy. It's the same with generics, you just have to have a variable that represents the type. R 0 value t. Easy peasy. Why generics? So generics reduce, loads of questions, great. Should get through this a bit faster. So why generics? Generics reduce repetitive code. You should care about generics because they mean you don't have to write as much code. It can be frustrating to write the same logic over and over again just because you have some underlying data types that are slightly different. Generics are used more often in libraries and packages. Generics give Go developers an elegant way to write amazing utility packages. While you will see and use generics in application code, I think it will be much more common to see generics used in libraries and packages. Libraries and packages contain importable code intended to be used in many applications, so it makes sense to write them in a more abstract way. Generics are often the way to do just that. Why did it take so long to get generics? Go places an emphasis on simplicity. In other words, Go has purposely left out many features to provide its best feature, being simple and easy to work with. According to historical data from Go surveys, Go's lack of generics has always been listed as one of the top 3 biggest issues with the language. At a certain point, the drawbacks associated with the lack of feature, like generics, justify adding complexity to the language. So, Go Developer Survey 2020 results. It's quite a lot. New modular survey design highlights. Who did we hear from? All these things. Code completion, navigating code. Sentiments towards Go. How satisfied are you with blah de blah? What does it say about the pain points? I'm interested what the other ones are. Pain points. I work on an existing project written in another language. My project/team/lead prefers another language. Go lacks critical language features I need. Go lacks critical libraries. Go is inappropriate for what I'm working on. Go lacks critical frameworks, blah, blah, blah. Okay, so the best things. So, generics, better error handling, null safety, functional programming features, stronger expanded, blah, blah, blah. What is the biggest challenge you personally face using Go today? Lack of generics, work with modules/rendering and package management, learning curve best practice docs, missing or immature libraries, convincing co-workers to use it. Yeah, okay, I get it. So Go's lack of generics has always been listed as one of the top 3 biggest issues of the language. At a certain point, the drawbacks associated with the lack of feature like generics justify the complexity of the language. Which code generics would be most likely to help with detecting whether or not a string contains a given substring, calculate the area of a circle, binary tree. Go's approach to language design is to support as many useful features as possible, to never add new features the language doesn't change, resist adding new features unless they're extremely important. Generics will probably be used more heavily in main packages, executable applications, library packages. Okay, 4 more for tonight, as long as they don't get too crazy and my brain holds up. So constraints. Well, you know what? No, we're going to call it there. I can see this starting to get a bit much. I'm going to call it there. I'm starting to feel it. Okay, that was a good stint tonight. Got through a fair whack. And tomorrow night should be the last one on this Go module. Then we haven't got another one on Wednesday, another stream on Wednesday or Thursday. We'll be back next week, and at that point we'll be starting the next Go course, so the next one in the series. It should be fun. I'm looking forward to it. So thanks very much for watching. Thanks for coming down and spending the time. If you're coming back from the future, let us know where you get that time machine, and have a good night. See you tomorrow night. So, auf Wiedersehen.